2, Grade 6, Advanced Post-Course Test, page 2. We always want to continue with reviewing past years, even grade 6, dare I say even grade 5. You want to just make sure that you are up to date with those skills, with those formulas and other things that maybe you just haven't seen in a while. So very important to always do this, what we call a cumulative review. So we're going to continue with the 6th grade cumulative review. And question number 18 says you travel 177 miles in 3 hours. Find the unit rate. So unit rate doesn't want to know in 3 hours. It wants to know 1 unit or 1 hour rate. So what we'll do here is we'll create a ratio. 177 miles in 3 hours is equivalent to how many X miles in 1 hour. So we set up a proportion, an equivalent fraction. One of the ways that we typically solve this is through cross product. We know that any equivalent fraction, the product across will be equivalent. So we write this equation. We can take this information and we can say 3 times X will be equal to 177 times 1. Now, many students would simplify this and they would write 3x equals 177. Now, we want to isolate for x. We want to find out what the value. 3 is multiplying x. The inverse of multiplying 3 is dividing 3. That allows us to cancel it out, to isolate my variable x, and then we always have to balance the equation. So whatever we do to one side, we do to the other. 3 goes into, so we would divide 3 into 177. 3 goes into 17 5 times. 5 times 3 is 15. You subtract 27 and 9. So 3 goes into 177 59 times, and x equals 59, or 59 miles. So the unit rate is 59 miles in 1 hour. That would be the unit rate. Now, how did I know that I needed, actually it shouldn't be in, we'll say, more importantly, per. 59 miles per 1 hour. Why? Because they had this word rate. So I knew I needed 2 units in my answer. Little small detail, understanding what we're reading, understanding, hey, don't just do the math. Comprehend the problem. Make sure you understand what they're asking for and what you need to provide. Number 19, you earn $28 for washing 7 cars. How much do you earn for washing 6 cars? So very similar to a unit rate where we wanted a single unit of rate. Here we just want to convert and we want to find an equivalency again. And we set up a proportional fraction, a ratio, a congruent ratio. And we don't know how many dollars for 6 cars. And we again can use cross product. We know that that product will be equivalent to this product. And we'll write our problem. So you have 7 times x equals 28 times 6. Now, really important here is we could simplify and write 7x equals 28 times 6. But then we would divide it by 7, and 28 times 6 is going to be some large number, and then I'm going to have to divide that by 7. So I'm actually going to divide by 7 here. And this inverse operation, the inverse of multiplying by 7 is dividing by 7, which would isolate my variable. 7 over 7 also equals 1. That would get rid of the 7. And then instead of multiplying 28 times 6 and then 7, I can just cancel these. 7, I know, goes into both of those numbers. 7 goes into 7 once. 7 goes into 28 4 times. And now I have 4 times 6, which is 24 over 1. But we would just write 24. So I know X, which represents the number of dollars, not cars. Cars is in the denominator. So the number of dollars. So I know that X equals $24. So how much do you earn for washing 6 cars? You would earn $24 for washing 6 cars. Now, writing that took how much time? 20 seconds? 30 seconds? And that shows comprehension. And that's what teachers want to know. Teachers are measuring your depth of knowledge. So providing detailed answers shows a deeper level of knowledge. How many yards are in 6 feet? So here we're converting. And if we have 6 feet, we have what I call conversion boxes. So a conversion box is equivalent to 1. It's a value of 1. So I need to get out of feet and I need to get into yards. So what's going to get rid of feet in the numerator? Yes, feet in the denominator. Feet in the numerator will cancel with feet in the denominators. Now, do I know how many feet are in a yard? Yeah, there's a conversion. There's 1 foot 1 foot. My bad. There are 3 feet in 1 yard. And so now I have canceled my feet. I'm in yards, which I want to get into. And now this 6 is in the numerator. This 3 is in the denominator. They have a common factor. 3 goes into 3 once. 3 goes into 6 twice. And now what do I have left in the numerator? I have 2 yards. And what do I have in the denominator? Just a 1. So my answer, how many yards are in 6 feet? 2 yards are in 6 feet. So 6 feet is equivalent to 2 yards. That conversion that equals a value of 1, because 1 yard is equivalent to 3 feet. That's a value of 1. It's kind of interesting. Kind of cool when you have different measures, different unit measures. Right, 43 over 50 as a percent. Well, we know percents are out of 100. And we know that if we want to get this, we want this fraction to be equal to hundredths. Now, before I showed you that we could cross product, correct? That's one technique. Another technique is proportional. We go from the known to the unknown. So this number, I know both pieces, 50 to 100. Well, 50 times 2 equals 100. And if I want it to be equivalent, then I'm going to, again, multiply that by that value of 1. 43 times 2 equals 86. So 86 out of 100, or 86 hundredths, is equivalent to 86%. Cool. And remember, 100% is equal to 1, so 86 hundredths would be equal to 86%. Nice, easy way. If we can convert that fraction to something over 100, we get to convert it into percentages real easily. 40% of what number is 26? We have this template, is over of equals percent over 100. And what we're doing here is we have two equivalent fractions, and that ratio is part is in the numerator over the whole. So if we use fractions having a part over a whole, and we create two of them, that's the easiest way. So here's our percent. So that's going to go in the percentage. So you're always going to set up a template that looks like this, a fraction template that has blank blank equals blank over 100. And those blanks, this top left is the bottom left is the of, the top right is the percent, and then you're always going to have it over 100. So we have my percent, so I'm going to put my 40, that's the percent part. So percent always goes in the over the 100, and then we can do is, oh, here's my is. So is 26, here's my is right here. So is, whatever is connected to the is gets top left, and then of, we'll make that red, of. And so of what number? So we don't know what that is. That's our missing piece. So we always use that to do that. That's nice. It's an easy way of utilizing a template, and these get mixed up and changed around and different things are missing. So this template is very easy, and you can apply it to any format that they come in. So now we have equivalency. I'm not going to use the proportion. I'm going to use the cross product one that we talked about. These two cross products will always be equivalent. So I have 40 times x equals 26 times 100. Again, I'm not going to multiply these and make them bigger. I'm going to isolate this x by dividing by 40. And it's a lot easier to cross cancel and simplify this fraction. First thing I'm going to do is I'm going to cancel the zeros. That's dividing it by 10 over 10. And then 4, okay, well, 4 and 26 have a common factor of 2. So 2 goes into 4 2 times, 2 goes into 26 13 times. And then 2 can go into 10. So 2 goes into 2 once. 2 goes into 10 5 times. And now I have a 1 in the denominator. 13 times 5 is 65. So 40% of 65 is 26. So 40% of 65 is 26. And that would be my answer. Good. Identify the terms, coefficients, and constants in the expression. You have 15x plus 12. So the terms, there are two terms, first of all. Two terms. Terms are separated by addition and subtraction. So term number 1 is 15x, and term 2 is going to be 12. So there are two terms. The coefficients, there's actually only one coefficient. The coefficient, in this problem, there's only one. The coefficient is the number in front of the variable. So the coefficient is 15. And the constant is the number that is a number. It is not a, doesn't have a variable attached to it. So the constant is 12. That's never going to change. That's why they call it constant. And there you go. Your two terms, 15x and 12. Your coefficient is 15 and your constant is 12. Evaluate y squared minus 3 when y equals 2. So we're going to use substitution, and we're going to substitute the value in for y. So you have 2 squared minus 3. And now we have orders of operations. We have exponents and subtraction. We always do exponents. So it's grouping symbols, exponents, multiplication and division are equal, and addition and subtraction are also equal. So we're going to do grouping symbols, exponents, then multiplication, division, then addition and subtraction. And so we're going to do exponents before subtraction. 2 squared is 4. That's 2 times itself 2 times. Minus 3 is 1. Write the phrase 13 less than a number p. So it is very important for us to understand this less than. Notice there is no is less than. That would be an inequality. So we know that less than is going to deal with subtraction. But we have to understand, is that less than attached to the p or the 13? It says 13 less than. So we're taking 13 from p. So the proper writing or translating that into an expression means it's not going to have an equal sign. So p minus 13, 13 less than a number p. Good? So that possession is very important to know where that negative or that subtraction is talking to. Simplify the expression 6 plus the quantity 4 plus x. 6 plus the quantity 4 plus x. Now simplifying, we can't simplify. These are grouping symbols. We can't add these because these are unlike terms. One's a constant, one is a variable. So we can't do that. And then we want to, there's an invisible 1 here that is outside that quantity. And that invisible 1 is multiplying each of these terms here. So we really have 6 plus 1 times 4 plus 1 times x. Now we know that multiplying by 1 will not change any value. You keep the same, but just at this stage, I want to make sure that everybody understands what's going on there. We're distributing that positive into there. And now we have like terms. These are like terms because they're both constants. And we would be adding them. And then here's an important thing for 8th grade that isn't taught to you in 6th grade. We want to put it in standard form. So standard form has an order, very much like orders of operations. We have orders of operations, so everybody does the same operations in the same order, no matter where you are, Australia, China, Bangladesh, New Zealand, etc. So standard form is very similar, is our answers need to have a same order. So we're going to do alphabetical order. When you have multiple variables, you're always going to do alphabetical order. And then if you're tied with alphabet, if you have the same variable, you're going to look to its exponent, and the largest exponent for that variable will come first. And then that'll be in descending order, so you'll have the highest exponent for that variable. And then last will always be the constant. So that's why variables will always come before constants in your expression. Kind of confusing because that's a very basic one, but we'll definitely be dealing with that later on this year in 8th grade. Use the distributive property to simplify the expression. This says 7 times the quantity 5x minus 6. So we have that, and we're going to distribute this. It's sort of like Halloween. When you go to a house and you have a group of people and they're distributing out Snickers, or they're handing out Snickers, everybody in that group gets a Snicker. So here we have these two kids trick-or-treating. They come to this house, and each of them is going to get this operation. So you have 7 times 5x plus 7 times negative 6. What I see in a lot of middle school students is they will write 7 times 5x minus 7 times 6. This is wrong. This is so wrong, and it's unfortunate that teachers still teach this. Books even show it in there. What are we distributing? We're distributing a positive 7. We see the positive 7 here. What are we distributing it to? We're distributing it to 5x and negative 6. That negative is attached to the 6. The notation should also reflect that. Notice in this wrong one, what are we distributing? It looks like, oh, wait, we're not distributing the same thing. That doesn't make sense. We're not distributing a negative 7. And we sure aren't distributing it to a positive 6. That's not a positive 6. That's a negative 6. That negative should stay with the term that it's attached to. So this is the proper technique and notation for it. And now we have 7 times 5x plus 7 times negative 6. We're going to do multiplication before addition. So 7 times 5x is 35x. 7 times negative 6 is negative 42. And I can't combine these. These are 35x's. This is negative 42. They are unlike terms. We can't combine them. So this is my final answer, 35x minus 42. Notice it's in standard form. The variable came before the constant. Number 28, you purchase Z items for $6 each. The total cost is $36. Write an equation that you can use to find Z. You purchase Z items for $6 each. So I'm going to multiply 6 times the number of items, and the total cost is $36. So we have 6Z equals 36. That is the equation. An equation has an equal sign. And then if we wanted to solve for Z, 6 is multiplying Z. So the inverse of multiplying by 6 is dividing by 6. And Z equals 6. So we had 6 items for $6 each. Definitely would cost $36. That makes sense. We can check that and make sure it's logical. Tell whether P equals 99 is a solution to P divided by 9 equals 11. So we have this equation, P divided by 9 equals 11. We're going to substitute 99 in for the value of P. And then we're going to simplify. I know that we can see this, but you should always simplify. Show that it is. Show that the left side. Simplify the left side down. Simplify the right side. And now we see 11 equals 11. Yes, I know that you know 99 divided by 9 equals that. That's a true statement. But let's simplify. Make sure to simplify completely. Make sure you simplify both sides of the equation completely. Good. You do these things, you're going to be very successful in high school and college. We're trying to promote practices, skills that are going to not only help you in 8th grade, but they're going to help you in high school and in college. So we're going to solve the equation. We want to isolate the variable x. We ask the question, what is happening to the variable? 11 is being added to it. The inverse of adding 11 is subtracting 11. We have to balance the equation. If we're going to take 11 plates off this left side, we have to also take 11 plates from the right side. Positive 11 and negative 11 make 0, leaving us with our x here. 15 minus 11 gives us 4, and that would be my solution. X equals 4. If we wanted to check it, a meticulous student would check their work. You start with the original problem, and now you're going to substitute that value in for. We're going to simplify it completely. Does 15 equal 15? Yes. Since this statement is correct, we know that the solution, our proposed solution, is correct. 9y equals 81. Again, we ask what's happening to the variable. It's being multiplied by 9. The inverse of multiplying by 9 is dividing 9. We're going to divide by 9. We'll always divide both sides by 9. Keep the equation balanced. 9 over 9 equals 1. So you're left with 1y, or we just write y. 81 over 9 leaves us with 9. We can check our answer. Checking doesn't take that long. We write our original equation. We substitute the value in. 9 times 9 is 81. We simplify both sides completely, and that worked. So we know that we were correct. That 9 is the solution. Number 32, the equation C equals 5t represents the cost C in dollars of T tickets for a play. Identify the independent and dependent variables. This is really good. So independent and dependent. So C is the cost, total cost. We might even want to write total cost. C is the total cost. 5 is the amount per ticket. And T represents the number of tickets that you're going to purchase. So we have T and C are our two variables. T is independent. T is the independent variable. We'll write that right here. Independent variable. It's independent because it doesn't depend on anything. Independent. That's what we're entering. How many tickets can we buy? Well, you can buy 1 ticket, you can buy 0 tickets, you can buy 10 tickets. So that is independent of anything. C, the cost, is the dependent. It depends. Your cost is going to depend on the number of tickets. So I won't know my cost until I know what number of tickets. So my cost depends on the number of tickets. That's why dependent and independent. So those are fun. Those are definitely interesting concepts for you to understand. Number 33, you have $10 and earn 25 cents for each cup of orange juice you sell. Write an equation that represents the total amount, A, in dollars you have after selling J cups of orange juice. Okay, that's interesting. So you already have $10. That's constant. That's something that's going to be part of the solution. So the total amount is going to be A. Let's not write that in green. So my total amount is going to equal A. And what's going to make up that total amount? Well, it's going to make up my $10. And don't mind the zipper in the background. My $10 is what I have in my pocket. And then I'm going to get 25 cents for every cup of orange juice that I sell. So if I sell 1, I'm going to multiply it by 25 cents. If I get 2 cups, I'm going to multiply that by 25 cents. 10, 15, 20, 30 cups, etc. So the number of cups I sell, I'm going to multiply by 0.25. And then I'm going to add the $10 that I have. Oh, J cups, sorry. I didn't see that variable. It's always good to use the variables that they provide. So I have J cups. I'm selling J cups of orange juice. All right. You have $10 and you earn 0.25 for every each cup you sell. Write an equation that represents the total amount A in dollars you have after selling. So that would be my formula for that situation. Number 34, use a graph to show the relationship between the time and the distance traveled. Okay, so we have to do a graph. A graph is going to have a y-axis and an x-axis. This is the x-axis. This is going to be the y-axis. And now, it doesn't matter which one you label. So time could be the y-axis or time can be the x-axis. It really doesn't matter. I'm going to do time as my x-axis. I'm going to make time, and time is in hours. We're going to label that. And then my y-axis, I'm going to make distance. So distance is going to be over here. Let's see if I can, whoops, sorry. Let's write distance. And distance is in miles. I'm going to label that. It's just always nice to know what your units are. So I'm going to, excuse me, I'm going to make the same increments. I'm going to make the increments of 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, so after 1 hour, this is 2, remember, we did increments of 2, so after 1 hour, I went 3 miles. So 1 is going to be between 0 and 1, and then 3, this is 0, 2, 4, so I'm going to have a dot here. That's going to be my 1 point. It's a relationship. 1 hour, 3 miles. 6 hours, so 2, 4, 6 hours, and then 18 miles. And that was up here, 2, 4, 6, 8, 10, 12, 14, 16, 18. So I have that to show the relationship between time and distance traveled. I only have 2 points. That's not much data, but it would look like that if we had to graph it. And then you would label it. It tends to have a label, but this is actually all they provide you. Find the area of the figure. So this figure, first of all, we have to know that it's a parallelogram. Parallelogram. Mr. Mac doesn't know how to spell parallelogram, but the area of a parallelogram is going to be base times height. So the base, important, base always must be a side of the object. So, little important fact there, the base must be a side. One of the sides, one of the 4 sides. And then the height doesn't have to necessarily be a side. It can be, it might be, but the height must be perpendicular. First, it must be perpendicular. That's 90 degrees, perpendicular to the base. That's part 1. And part 2 is it needs to go from the bottom to the top. Bottom to the top of the object. Hence why it's height. So notice we get this perpendicular sign, this 90-degree angle. It is perpendicular to the base, and it goes to the top of the object. Okay, so very important. These 2 things must be true. So my area equals my base. This is going to be my base. And this is going to be my height. So my base is 7 inches. Times my height, which is 12 inches. Now, units are very similar to variables. So we have a coefficient and we have a unit. So the first thing we have to do is we have to multiply the coefficients, or the number of inches. 7 times 12. So 7 times 12 is 84. And then this is the other important thing that students don't remember about. We're going to multiply inches times inches, which equals inches squared. Inches squared. So the area of this parallelogram is 84 inches squared. Very important on the unit. You have to include the unit in your answer. Now this is a kite, and Mr. Mack doesn't really remember the formula for a kite. Okay, so that happens in life. That's realistic, right? So how do I fix that? How can I find that? Well, a nice alternative is I see that I have 4 triangles. I have 4 triangles. So I have triangles, 4 triangles, and I have the information, 4 triangles. So we'll say, well, first of all, area of a triangle equals base times height divided by 2. Okay, so I'm going to say triangle 1. So we'll call this triangle 1. This is triangle 1. So area, let's make that red. So T1, triangle 1, the area is going to equal the base, that's 6 centimeters, times the height, it's 6 centimeters. Notice the perpendicular sign, and then divided by 2. So instead of multiplying 6 centimeters times 6 centimeters and then divided by 2, I'm going to cross cancel already. I'm going to cross cancel 2 and 6. 2 goes into 2 once. 2 goes into 6 3 times. And that leaves me with 3 centimeters times 6 centimeters over 1. 3 times 6 is 18. Centimeters times centimeters is centimeters squared. So that is going to be the area of triangle 1. Well, triangle 2 has the same dimensions. So T2 is also going to be 6 centimeters by 6 centimeters. So I know that area of triangle 2 is also going to be 18 centimeters squared. Now, let's do the third triangle. Let's do the top left. That's going to be 11 centimeters with a 6 centimeter height. So area equals 11 centimeters times 6 centimeters divided by 2. Now, this time, 2 doesn't go into 11, but 2 goes into 6. So 2 goes into 2 once, 2 goes into 6, not 6 times, Mr. Mack. 3 times. And what are we left with? 11 centimeters times 3 centimeters. And that is equivalent to 33 centimeters squared. 11 times 3 is 33. Centimeters times centimeters is centimeters squared over 1 is just 33 centimeters squared. And last one, triangle 4. Triangle 4 again has 11 and 6. So that area is going to be the same, 33 centimeters squared. Now we can add the 4 triangles up. 18 centimeters squared plus 18 centimeters squared plus 33 centimeters squared plus 33 centimeters squared. Okay, so 18 and 18 gives me 36 centimeters squared. I'm adding so that unit stays the same. 8 and 8 is 16, carry the 1. 33 and 33 is 66 centimeters squared. And then 36 and 66 gives me 12. 102 centimeters squared is the area of that kite. Of the kite. Now, I don't know if I could have, let's see where, if you have, let's do a little, let's do this. We can always like to think on the fly. So, area of a kite when given, not the side, the diagonals. Those are diagonals. So, how many people knew that formula? I don't know. I didn't remember it. But the nice thing was that I was able to decipher it. So let's duplicate this. Can I do that? Let's try this. Let's clone the page. Let's erase the ink. Let's post that little... What happened to my picture? Well, I guess I didn't. Let's take that picture again. Kite. Let's post that. Let's shrink it a little bit. Okay. Whoa! Let's move that. Perfect. Okay, so knowing that the area equals diagonal, so 6 and 6 is 12, so my diagonal is going to be 12 times my Q value, which is 6 and 11, which is going to be 17 divided by 2. Again, I'm not going to multiply 12 times 17. Why do I want to make bigger numbers? I'm going to actually cross cancel early. And now we have a number 6 times 17 over 1. 17 times 6, 42, 102. And we're multiplying, ooh, I forgot that's centimeters times centimeters. So centimeters squared. And look, we got the same value. That doesn't look like a 0. But we got the same value, just really a whole lot faster. So we got 102 centimeters squared, and we got 102 centimeters squared. So remembering that formula is kind of important. It'll save you time, and that's important in math, is adding to that time bank. So this is not any figure at all. This is some obscure figure. So what I'm going to do, because this is an irregular object, I'm going to cut it into pieces that I can do, into shapes that I do know. That's a rectangle. So I have an area. So 1 is the area of a rectangle, which is technically, I guess it's length times width. And then my other figure is a trapezoid, area of a trapezoid. An area of a trapezoid is base, it's b sub 1 plus b sub 2 divided by 2 times the height. So it's the average of the bases. Okay, and bases, these bases have to be parallel to each other. So that's going to be 4.8. That height, the height of this is going to be 9.6 minus 7.2, which is, doesn't take any time, 9.6 minus 7.2. You don't get extra points for doing it in your heads, kids. So it's better to just do the workout. So we know that this height is going to be 2.4. Don't know if that looks like 2.4. We'll do it this way. 2.4 meters. And everything is the same unit, so that's important to pay attention to. They like to trick you there. All right, so we have our rectangle, length times width. So our length is going to be 4.8 meters times our width is 7.2 meters. Let's do that math right there. 7.2, 4.8 products. 8 times 2 is 16. Carry the 1. 7 times 8 is 56. Plus 1 is 57. Let's take the place value. We're going to the tenths place. So we need to start in this place. 4 times 2 is 8. 4 times 7 is 28. 6, 15, 14, 3. We have 1, 2 decimal places that we have to account for. And we always start here, and then we'll move here. So that's going to equal 3456. 3456 is that area. Area of part 1 is 34.56. And we are multiplying meters times meters, or meters squared. Now the trapezoid, we have base 1, which is 4.8 meters, plus base 2, which is 9.6 meters, divided by 2 times the height, which is 2.4 meters. So we're going to add those two together. And 4.8 and 9.6, again, you don't get any bonus points for doing in your head. 9.6, 4.8, which is 14. And that's 14 also. Bring down the decimal. That's going to be 14.4 meters divided by 2 times 2.4 meters. And we have to take half. We can take half of either one because both of these are in the numerator. Those orders of operations are those are commutative property. So I'm just going to take half of this. Half of 14.4 is 7.2 meters. Don't know if you know how to take half of that. That's pretty simple. And now we're going to multiply 7.2 times 2.4. 4 times 2 is 8. 4 times 7 is 28. Go to the next place value. That's 4 and 14. That's 8. That's 12. That's 7. 1. You have 2 decimal places again. 17.28. And we multiplied meters times meters, which is meters squared. The total area of that object is 17.28 meters squared. Oh yeah, that was a good one. Probably an hour.